Value and reference types, specifically structures and classes, they have quite a lot in common. You can use either to store data and perform actions. What makes them different is how they work behind the scenes. One thing value types aren't that good at is storage efficiency. Remember, structures store their data on the stack, which in theory makes accessing it faster. However, using the same data from multiple places isn't very straightforward. Moreover, when you try to copy a variable that points to a value type instance, its data gets copied right away. In most cases, that's exactly what you want, because when you have a separate data copy for each variable, you don't risk accidentally changing the others. But as you can imagine, duplicating data every time is not quite efficient. That's especially true for large objects. For example, imagine you've got an array that holds 1,000,000 elements. You pass it to a function that maybe takes every other element. Or maybe that's all the elements together. It doesn't make a lot of sense to copy every element in this case, does it? In that scenario, you don't modify any data, so there's no risk of unintended changes. The function parameter could perfectly have used the same data instance that already exists. Now imagine a different situation. You've got the same array with 1,000,000 elements, but now your task is to reverse them while keeping the original object intact. You obviously need a separate copy in that case, otherwise you'll mess up the data. Wouldn't it be nice if the system somehow knew when it's safe to reuse the data in memory?